this set of practice problems, I'm going to go over the equal payment series or the uniform payment series in Chapter 3. So the question that we have is, what is the future value 10 years from now if you invested $10,000 each year for 10 years? Assume an interest rate of 6% and draw the cash flow diagram. So the benefit of using the equal payment series is that rather than having 10 different calculations for 10 different payments, some smart person prior to us has come up with what that equivalent formula would be. And that is the equal payment series. So I'm going to draw my cash flow diagram. I need 10 years. And I want to find out what is the future value in 10 years' time of an investment of $10,000 each year for 10 years. So because this is an equivalent payment, I'm going to draw a line underneath them and say that is all $10,000. And as we talked about in class, this is typically represented, your equal payment is typically represented as an A. So the formula that we have for this problem is we want to find out what the future value is. And rather than calculating each one of these calculations, we can use a formula that says the future value is A multiplied by 1 plus I to the n minus 1 over I. Now, this would be the same thing as saying the future value is equal to $10,000 multiplied by 1 plus I to the 1 plus $10,000 multiplied by 1 plus I to the 2 plus $10,000 1 plus I to the 3 plus $10,000 plus I to the 4, etc., all the way to $10,000. Sorry, that doesn't look very good. If we kept going, I'm running out of room though, so 1 plus I to the 10. So these two things are equal. And obviously, the first way is much easier. So if I input the information into here, I'd have $10,000 multiplied by 1.06, and 6% is my interest rate, to the power of 10 minus 1, all over 0.06. Now, the other thing that you've learned is this factor here can be looked up in an interest table. So there is a value for a compound amount that we can look up in an interest table, because f equals a 1 plus I to the n minus 1 all over I is equivalent to a multiplied by the interest factor. What is f given a at that interest rate for that period of time you're talking about? And in this case, we're talking about $10,000 multiplied by what is f given a at 6% interest for 10 years. So we can actually look this value up in an interest table. Let's find one. I have one open here, and it's open at 6%. And I'm going to look for the compound amount factor under this column. Find f given a, right there. And so I'm going to pull out a number off this table. So I know I want it in this column because I want f given a. And I need to look for 10 years. So I'm going to go down to 10 years, right here. And I'm going to go across until I get to f given a. So right where my cursor is, 13.181 is the factor that I want. So we're saying that this equation is equivalent to $10,000 multiplied by 13.181, which is the same as saying $131,810. That is the equivalent amount. So let's double check that we believe that this interest factor is equivalent to the equation. So let's continue to do the math on the other formula. $10,000 multiplied by 1.06 to the 10 minus 1 all over 0.06. You really have to make sure you do your order of operations properly on this equation. That's going to be the same as $10,000 multiplied by, what is 1.06 to the 10? I'll get my calculator out here. And that is going to be 1.06 y to the x 10 is 1.790848. So I get 1.790848. Sorry, let me rewrite that. It's a disaster. 0848 minus 1 over 0.06. I'll come back down here. 10,000 multiplied by 0.790848, because we subtracted 1, and that's going to be divided by 0.06. 10,000, and when I work that number out, I get 13, lo and behold, 13.18079, which is the same as what we got in our table. Okay, let's work on the second question. What is the present value required if you want to take out $2,000 each year for 10 years? So the cash flow diagram for that would look like, what do I have to invest now at year 0 if I wanted to take out $2,000 each year for 10 years? 4, 5, 6, 7, 8, 9, 10. And that's $2,000. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years. So I'm looking for a present value. What is P given the equivalent amount, $2,000? So I have A and I want P. So let's look up the formula for that. I know that there's two ways to do this. My formula is P is equivalent to A multiplied by I plus 1 to the n minus 1 all over I multiplied by 1 plus I to the n. And when you write this formula out, you begin to say, okay, now I can see why people start to choose to use the interest factors instead. So the equivalent interest factor is, what is P given an amount A at a certain interest rate over a certain number of years? So let's solve this both ways and make sure we get the same answer. Okay, so in this equation, we have an interest or equivalent amount of $2,000 multiplied by 1 plus our 6% over 10 years. Sorry, I'm missing a 0 there. Okay. Do some math on that one. So I'm just doing this math on Excel here right now. Zero 0.107451 equals 2 by 0.79084 divided by 0.10745, which equals 2 by, sorry, doing the math, 7.36087, and I get a final answer of 14,000 $14,720 plus some change. Okay, if I solve it using the interest factor, I have my $2,000, and I'm going to go to my lookup table. And this time, I'm going to look under the what is P given A, which is the sixth column over. And I'm going to look under 10. My interest factor is 7.360. Which, not surprisingly, same. So I'm going to get approximately the same amount here.